Okay, so we have to be able to, for the higher tier anyway, convert what we call reoccurring decimals or reoccurring numbers into fractions. So what exactly is a reoccurring decimal? Well, simply put, it's a decimal that doesn't end. A sort of. There has to be a pattern of numbers in it that simply keeps on reoccurring. One of the simplest ones that you will come across is a third. A third as a fraction is fairly simple. We do 1 over 3. But as a decimal, it becomes 0.3 and the number simply reoccurs forever. As a decimal, a third can't be written because the number essentially goes on forever. The 3 is simply reoccurring. Now, in a number like this, we can represent it in a slightly different manner. What we do, as you can see by here, is we write down the number that, or any numbers that reoccur. In this case, the only number that's reoccurring is 3. And then we put a little point up by here to show that the 3 reoccurs. So these two numbers or representations here are actually the same thing. But really, you can't in maths put simply dots to show something goes on forever. So instead, we use this format down here. Now, it doesn't always work the same. For instance, by here, I've now got a number 0.123, and in that you can see that 1, 2 and 3 are reoccurring. It's not one number now, just like with the 0.33 and 3 reoccurring. It's actually 3 numbers that are constantly reoccurring in a pattern. It's a reoccurring decimal, but with 3 numbers. So what we do is we put one dot the first number that reoccurs and another dot at the last number that reoccurs. So whenever you've got a reoccurring pattern that is 2 or more, you put a dot up here after the first number in the pattern that reoccurs and a dot up here after the last number that reoccurs in the pattern. So how do we actually convert them then into fractions? Well, this is going to involve a little bit of algebra, and we haven't actually started algebra yet, although it's coming around the corner. Basically, what I'm going to do to start with is represent the 0.3 reoccurring, and I haven't done the number fully here, I've just simply used 6 decimal places. I'm going to represent it by the letter n. So again, we'll talk a little bit about what these mean in algebra. Basically, we're saying that the letter n has the value of 0.3 reoccurring. Think of it as if I put 0.3 inside an envelope, the envelope then has the value of 0.3 reoccurring. So if I gave that envelope to anybody, they have got 0.3 reoccurring inside it. So n is 0.3 reoccurring. Now, because one number is reoccurring, what I'm going to do is multiply it by 10 to the power of 1, or 10. If two numbers had been reoccurring, I'd multiply by 10 to the power of 2, or 100. Three numbers reoccurring, 10 to the power of 3, or 1,000, and so on and so on. But in this number, we've only got one reoccurring, so I'm going to multiply it by 10 to the 1. And what that's going to do is it's going to move all the numbers to the left, or the decimal point to the right. So if I have 10n, if I have 10 of those envelopes, if you like, I'd have 10 lots of 0.333 recurring, which means I'd have 3.33 reoccurring. So, first of all, I've got the 0.3 reoccurring represented by n. Because only one number is reoccurring, I'm multiplying it by 10 to the power of 1, or I'm multiplying it by 10 to give me 3.3 reoccurring. And remember, these 3's go on forever, an infinite amount, so they don't just suddenly come to an end, they reoccur, they go on forever. But that gives me 10 lots of n. Now then, what do I get when I take away one lot of n from 10 lots of n? What do I get when I take away this number, 0.3 reoccurring, from 3.3 reoccurring? Well, maybe some of you can work it out, but simply put, all we're going to do is do 3.3 reoccurring, take away 0.3 reoccurring, and all we've got left is 3. So what I've done is I've got rid of all the numbers to the right of the decimal place. So that's told me that if I've got 10 lots of that number, 10 lots of n, and I take one lot of that number away, one lot of n, it gives me the number 3. Keep on following it and you'll see why we're taking this route. 10 lots of n, take away one lot of n. 10 envelopes, take away one envelope is 9 envelopes, 9n. So in other words, 9 lots of those n's must be equal to 3. 9 of those envelopes is equal to 3. Now I want to find out what one envelope is, not 9. So if I divide the number on the left by 9, if I divide those 9 envelopes by 9, I'll be left with one envelope. And if I divide, but if with algebra, whatever you do to one side, you've got to do to the other. So if 9 lots of n is equal to 3, dividing 9n by 9 gives me 3 divided by 9. 9 envelopes divided by 9 is the same as 3 divided by 9. So n, the number 0.3 reoccurring, is equal to 3 over 9, which simplified, as we've done in fractions, is 1 over 3. Now, what I actually did was it seems when you look at it and you begin to understand it, you'll start, well, didn't you just go back to the starting number you had? And I did. I started off with n, and throughout this process here, I've just looped it back to coming out of as n. But the important thing is I started as a decimal, a reoccurring number, and now I'm back to a fraction. So I've converted it from a decimal place, a decimal reoccurring number, into a fraction. So let's have a look at another one. By here I've got 0.121212. So n is 0.12 reoccurring. And because there are 2 reoccurring numbers, 1, 2, 1, 2, 1, 2, and so on, I'm going to multiply it by 10 to the power of 2, or 100. Another way to think about it is that there are 2 zeros. If there's 2 decimal places I got to move it, then the number has to have 2 zeros. If it's 3 decimal places I have to move it, the number has to have 3 zeros, and so on. So multiplying it by 100 lots of n, it's equal to 12.1212 reoccurring. So I've moved the decimal place twice to get all the reoccurring numbers, the 1, 2, that's the bit that's reoccurring, onto the left side of the decimal place. So 100n is equal to 12.121212 reoccurring. Now I'm going to take one lot of the n away, just like I did in the last one. We always take one lot of the n away. So 100n take away n, 12.12 reoccurring take away 0.12 reoccurring, gets rid of everything after the decimal place, leaving me with 12. In other words, 99 lots of n is equal to 12, but I want to find out what the value of n is, what n looks like as a fraction, not 99 lots of n. So I divide them both by 99. I divide the 99n by 99, making it just n. And I divide the 12 by 99, making it 12 over 99, 12 divided by 99. I simplify. The number 3 can go into both of them, so we're left with n is 4 over 33. So in this reoccurring number, 0.12 reoccurring, n, the number is actually the same as 4 over 33, 4 33rds. So that's how we convert into a recurring number into a fraction. You classify the number as n, you multiply it by 10 to the number of decimal places that are repeated, in this case 2. You then take away one lot of n to give us a nice whole number, and then you divide both sides by whatever number is now in front of the n in order to have it in a fraction format.